Today's video is sponsored by Energy Sage. Visit the link in the description to find local, verified solar experts and community projects in your area. And if you are in the state of California, keep watching to find out how you'll want to get your solar project permit submitted to your utility before California switches to net metering 3.0. Whenever we make a video about the environmental impact of electric vehicles, and often when we just make videos about electric vehicles full stop, we get some clever people in the comments section, and I'm using the term clever here sarcastically, trying to tell us that electric cars aren't clean because reasons? Usually, the reasons cited revolve around the carbon footprints associated with electricity grids around the world, and sometimes the reasons cited revolve around the carbon footprints as well as environmental and ethical concerns revolving around the use of raw materials found in electric car battery packs. Sometimes, commenters also complain about the recyclability of EV battery packs, but we've debunked all of those concerns so many times that I'm just going to leave you a long list of videos to go and watch after this one if any of the concerns I've just listed are in your bag of worries. By the way, if you are a parent with a little one, go and read The Huge Bag of Worries. It's a good book and it was one of my children's favourites when they were still microhumans, which they aren't anymore. While automakers are doing a lot to try and clean up their part in the carbon footprint of a modern EV, several are now producing their EV and their EV battery packs at facilities powered by renewable energy. We can, of course, clean up our carbon footprint of our cars after manufacturing by ensuring that we charge them using cleanly produced electricity. And while, yes, the majority of an EV's carbon footprint comes from its production, being able to charge your car using power you've generated on your roof is not only a great way to reduce your carbon footprint, but it can also save you money long term. Which is why we have partnered with our friends at Energy Sage on this month-long exploration of getting solar at home. Later this month, I'll show you how to fall in love with solar. I'll cover what you need to know about those adverts that promise to put free solar panels on the roof of your home, and I'll help you learn how to pick the best solar system for your house. But today, I'm starting with some common terms that you're going to need to know if you're about to invest in solar on the roof of your home. So let's get on with it. Kilowatt, kilowatt-hour. The first set of terms we're going to deal with today revolve around the way that we commonly discuss solar power and energy, using three related terms: kilowatt, kilowatt-hour, and also kilowatt-peak. A kilowatt is a measurement of how much electrical power is either being produced or consumed at a given moment in time. Just like kilogram is 1,000 grams, a kilowatt is 1,000 watts. And because it's easier to say things like 2 kilowatts rather than 2,000 watts, the kilowatt is the preferred unit of measurement for things like EV motor power and the maximum rate at which power is being transferred. The larger the number, the more power is being transferred in a given instance. If kilowatts is how much power is being transferred in a single instant, a kilowatt-hour helps us figure out how much electrical energy is transferred over a period of time. Officially, a kilowatt-hour is the equivalent of providing 1 kilowatt of electrical power to something for an entire hour. But because it is calculated by multiplying the instantaneous power being transferred by the amount of time in hours that power is flowing, it is possible to use 1 kilowatt of energy in less or more time than 1 hour. For example, a 6 kilowatt EV charging station will transfer 1 kilowatt hour of energy in just 10 minutes, but our high-end gaming PC that pulls 500 watts from the wall will take 2 hours to get through that same 1 kilowatt hour of energy. The final kilowatt-related term, Kilowatt-Peak, is one that you'll need to know when it comes to discussing solar panels, because it's the measurement of what the physical maximum instantaneous power can be produced in ideal conditions. A solar system with a 15 kilowatt peak rating is theoretically capable of generating up to 15 kilowatts of energy at a given moment in time when everything is just perfect. And that means they're in direct sunlight with no clouds, are perfectly clean, and it's solar noon. Since I just covered Kilowatt-Peak, it seems like a good time to add in the term production guarantee, since it is a kind of related solar term. While it's difficult to predict exactly how much energy your solar system will generate on a given day, more than a few days in advance that is, because, weather, solar installation companies use special software to help them calculate predicted solar generation totals over the lifetime of the solar panels. Because the software takes into account things like where you live, your geographic location can dramatically impact solar production, and things like how your home is oriented in relation to the path of the sun, your installer is able to give you an idea of how much energy you'll actually produce on average per year, and thus how much money you stand to save based on current electrical prices from your local utility. A production guarantee is essentially one step further than this, promising that your system will generate a given amount of energy over a set period of time. If your system underperforms over time, the production guarantee gives you, the customer, a way to get compensated for that delta between what you were told the system could offer and what it actually offered. Peak sun hours. Just like the other terms I've already covered, peak sun hours is a way of helping set up a reasonable expectation for your photovoltaic system. As the name might suggest, peak sun hours is a measurement of, under ideal conditions, how many hours per day your home receives more than 1 kilowatts worth of solar radiation per square metre as averaged out over the course of the year. The closer you get to the equator, the naturally higher the number of peak sun hours you will receive in a given day. Why? It's all due to the fact that sunlight is more concentrated at the equator than at the poles because physics, and the fact that we do indeed live on a giant oblate spheroid hurtling through space. I'd actually add Monty Python here, but I'm not entirely sure that we'd not get copyright struck for that, so let's just leave an awkward silence instead. Inverter. Because of how solar panels work, electrical energy flows through them in one direction. You can't reverse the polarity of the neutron flow to make your solar panels giant lights after all, however hard you try. And that means the power you're generating is direct current rather than alternating current, the latter being what utility companies pump into most homes to come out of the sockets on your wall. Side note, if you are interested in why we use alternating current rather than DC for mains wired home electrical systems, I highly recommend that you watch The Current War, which covers the rivalry between Sir Thomas Edison and Nikola Tesla over the two competing ways of producing and transmitting electricity in early 20th century New York. Because solar panels produce direct current electricity and your home needs alternating current, you must use a device called an inverter to convert DC into AC. Again, if you are interested in how they work, I'll leave a link below to a video from Electroboom. In a traditional solar setup, you'll have a series of solar panels connected together in series. That's a fancy way of saying daisy-chained together, with a single inverter converting the resulting DC power into then AC power that you can use in your home. Sometimes the system will have a single string of panels, and sometimes you'll have a few strings that each have their own parallel connection to the inverter. Microinverter. Microinverters are like mini-me inverters. Instead of taking all of the DC power generated on your roof and converting it all to AC, each microinverter takes power from just a few solar panels and then converts it to AC on your roof before then feeding it down to your electrical panel. Why do these exist when inverters work just fine? Well, Simply put, microinverters make it easier to maximize the power that your solar panels are capable of producing. This is especially true if your roof spends some of its day in partial shade. When solar panels are connected in series and their combined power goes through an inverter, a single solar panel in shade can reduce the amount of power your roof can generate. Basically, the more sunlight hits your panels, the easier it is for electricity to flow. So reduce the amount of sunlight and you increase the panel's resistance, which then reduces how much current can flow and therefore how much power can be produced by the panel and the other panels in that string that can flow through the electrical circuit. Microinverters can help get around this problem by breaking up your roof solar panels into smaller, bite-sized groups that each have their own small microinverter, maximizing the amount of power that you can ultimately generate. Off-grid or on-grid? Having decided you want solar panels on your home, you'll probably be asked if you'd like an off-grid or on-grid system. The latter is more usually called grid-tied. The answer will likely depend on your own personal preference and also details of your home. In an off-grid solar application, your solar panels generate power on the roof of your home, and that power is then fed to your home electrical system, usually via an inverter, to run things in your home. Any excess power you generate is then fed into a battery pack that's connected to your home, so when the sun isn't shining, you can still use power you generated earlier to keep things running. An on-grid or grid-tied home does things slightly differently. It has an electrical connection to your local utility. It can use power from the electrical grid at night time or during periods of low solar generation, but it can also feed power back to the electrical grid when you generate more power on your roof than you actually need. To have a grid-tied solar system, though, you will need a few things. Permits. The first of these things are a set of proper permits. Depending on where you live, exactly which permits you'll need will vary, but usually you'll need an electrical permit from your local county building department, as well as a building permit. These two pieces of paper are formalities that your solar installer will file on your behalf and includes details of the mechanical aspects of your solar system, like how the panels are affixed to the roof, as well as things like the electrical connections that will be made to the home. These permits will be filed before work can start, and when everything is complete, you'll then need to have the work those permits detail officially inspected and approved. Again, your solar installer will help you through that process. Sometimes there will be additional permits you'll be required to file though, but this is one of the reasons it's important to pick a good local installer who knows your local regulations. Which brings me to today's sponsor, EnergySage. EnergySage is an online service in the US that helps homeowners connect with local, verified solar installers who really know their stuff and can help you navigate the process of installing photovoltaic solar panels on your home. They can also help you join a community solar program. We used EnergySage when we were looking for installers willing to help us put solar panels on the roof of this building, and our EnergySage verified installers were professional, knowledgeable, and even put us in touch with an amazing credit union to help us finance our solar panels for as low a monthly payment as possible. And if you live in California, now is the time to go solar to maximize those savings. The new state policy, NEM 3.0, goes into effect at 5 p.m. Pacific on April 14th, 2023, and that will drop your solar savings by 60%. So in order to qualify for the current higher savings, you'll want to get in touch with local installers right now to lock in your home. To avoid price gouging, high sales pressure tactics, and to get quotes from trusted, verified installers, follow the link below to sign up for EnergySage's free, no-obligation service and get that ball rolling today. If you do choose to use an EnergySage installer for your solar project, we here at the channel will get a small referral fee, so you'll be helping us too. Interconnections. As the name might suggest, an interconnection is the official name given to the electrical connection between your home's solar system and the electrical grid. If you're going for an off-grid system, you won't have to worry about this, but if you're going grid-tied, as most people do, you'll need to know about it. An interconnection request is an official piece of paperwork filed with your electrical utility company that tells them you want to generate your own power. It's required because the utility has to know that you're injecting power into the grid as well as consuming power from it. And in order to get your interconnection request approved, your home may need to get an inspection from the utility company, and they may need to upgrade the power lines to your home. That said, as long as the solar system isn't massive and you're not in an area with an already overstressed electrical grid, this is usually just a formality. However, after the request has been approved, your solar installation can go ahead, after which point your utility will then need to come back out to your property to do two more things, which I'm about to cover. Net metering. The first thing your utility will want to do when your system is installed is come out and inspect it. As part of that inspection process, they will carry out some tests to make sure your system is properly functioning, and they'll also make sure that your solar system properly disconnects from the electrical grid if there is a power cut. This is a legal requirement to prevent utility workers from being electrocuted by backfed power going to the grid. At the same time, they will usually install an upgraded electrical meter that records power flow into your home and then back out to the grid. This allows for something called net metering. Depending on where you live, and it really does depend on local politics, you might be able to earn money by feeding excess power you generate from your solar system back to the grid. Sometimes you'll see this represented as a physical monetary credit on every utility bill. Sometimes, as is my case, it's just an energy credit you can use to offset higher demand and lower generation periods in winter months. How much you'll earn also does depend on local regulations, and in the case of places like California, when you first applied for an interconnection to the grid. As I mentioned earlier, California is about to change its net metering program to dramatically reduce the amount of money the utility company can pay you per kilowatt hour of electricity you generate. And while it's not mentioned in its own section, it is worth acknowledging here that where net metering is frowned upon or not financially beneficial, having an EV or a static battery pack like a Tesla Powerwall or similar can help you reduce your dependence on the grid without being penalised for generating more power than you use. And yes, some places do have restrictions on what's considered legal when it comes to total solar panel size. Permission to operate. Once the utility company has completed the inspection of your solar system, you'll be given the official go-ahead by the utility to flip the switch and start producing your own clean green power, feeding any excess back to the grid that you generate. While this is usually a formality, it is super important to note that power companies take a very dim view of people feeding power back to the grid before getting their PTO, and you can actually be fined a significant amount of money if you try and do that before getting that official approval. As I said earlier, this is because you might not only electrocute a line worker, but as part of that final PTO process, your utility will likely mark your home's connection to the grid with a warning sticker somewhere that says backfeed potential or something similar. This is to protect everyone and make sure that nothing unexpected happens when your power goes out during a storm. Islanding grid forming. Which brings me to what happens when the power goes out. If your solar system doesn't have any kind of backup system, it will automatically switch off if the mains grid goes down. It does this because if you are generating more power on your roof than you're using, that power has to go somewhere. And if it can't go down the grid because the grid is down, it could burn down your home electrical system. However, if you do have a backup system that is a battery-based one, be it a vehicle-based system or a battery connected to your home, you can run in what's known as islanding mode, provided your system is properly set up. In this operational mode, you'll be able to charge your batteries from solar panels and feed power to your home, but no power will then be fed to the electrical grid, creating an island of power that you can use. A similar but very subtly different application of the same idea comes in the form of grid-forming inverters. Unlike regular inverters, which are frankly pretty basic, in how they take DC power and turn it into AC power, grid-forming inverters can operate during a power cut by turning solar panels on or off in small groups to ensure that you're only generating as much power as you actually need when the local grid fails. Warranties. I know you all know what warranties are, at least I would hope you do. But when discussing solar installations, there are 3 different types of warranties you should know about. First, there's the installation warranty that covers the physical installation of your system, including everything from the mechanical connections that your panels make to the roof through to the wires that connect everything together. If the solar panels were to start flapping around in a storm, the installation warranty would be where you'd look first. If the wires were coming loose between the solar panels and the inverter, you've guessed it, it'd be the installer warranty that you'd need to look at. But if it's the inverter itself that fails, or the panels, then you need to look at a manufacturing warranty. Warranties for solar panels vary according to manufacturer, and the same is true for inverters. Here we actually have 3 warranties, one for the installation, one for the panels, and one for the microinverters. Our installation warranty is the shortest in terms of time, and our solar panel warranty is the longest. So be sure to ask which is which when you're planning your own system. So there you have it. Terms you should know about when it comes to solar installation. Have I missed anything? Have you come across a term that I haven't explained? Don't forget to tell me below. And on that note, we're done with today's video. And if you want to know more about the classic PowerBook 5300 behind me, stick around until after the credits and I'll tell you more. If you like this video, you know what to do, and feel free to tip us with a super thanks. The comments are open for your thoughts, as is our Discord chat room. Link is below. And if you want more, subscribe, hit the bell, and follow the links to support us regularly through a YouTube membership or a Patreon subscription. You'll also find links to Ko-fi, Bitcoin, and Swag stores. And do check us out on Mastodon. We have our own server. We'll make sure the link is below. Scrolling on my right is the list of amazing charged up supporters, and shout outs go out to our self-driving tier supporters: Mike Weeder, Tony Moss, Linda Irish, Sean Tucker, Patrick Boyarski, Paul Nelson, Chris Maxwell, Brian Newton, Michael Goad, Bennett Elder, Andrew Martin, Pedro Moa Pinheiro, Brophy Wolf, Chris and Michael Johnson, Tazza in the Gong, Dan Blair, Peter Dillinger, Gordon C, Stephen O'Donoghue, Carl Hodgson, Anthony Coates, Regine Fellows, Denny Hyde, Chris Centaur, and Jim Burness. Finally, out of this world, thanks to our top tier supporters: Robert Flannery, CPU Freak 101, Andrew Glenn, Anonymous Freak, JP Fagerbeck, Joe Bresney, John Lyons, Rory Litwin, Kevin Barbridge, Dave Kitchen, Aaron Hahn, Laura Reynolds, Marcel Ward, Matthew Drobnak, Paul Conway, Reggie Watts, Will Graylin, and Ian. Finally, thanks to Energy Sage for supporting this video. Follow the link below to find out how easy it can be to get verified, trustworthy solar experts helping you make that step towards energy self-sufficiency, either with solar on the roof of your home or through a local community solar project. I and the rest of the team will be back soon with more videos, but until then, keep evolving! So in case you haven't noticed, there is a PowerMac 5300 CE behind me. It's not technically a CE, but it has the CE screen. It's only got the 100 megahertz processor. I am a big fan of retro Macs. I used to work on them when I was at music college, and so I've decided to put some of my collection on display. I've recently acquired a G4 Sawtooth Power Mac, which hopefully will be on set next week. I've got the iMac, I've got a few other machines, but if you have vintage Apple laptops or desktops that you would like to donate to the channel and see on this stand behind me, do let us know in the comments below and we'll see what we can do. I would love to get hold of a first generation PowerBook 100. I used to own one and then it broke, and I was 20 and decided to just throw it away. I recycled it and gave it to someone for parts, and I regret it a lot.